Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving a problem which is related to subsequence, and it's printing subsequences whose sum is k. Now in the previous video, if you have seen that, please make sure you watch that before watching this. If you've seen that, you know how to print subsequences. We specifically use the technique of take and not take. Now this problem we will be solving this particular problem first, and we'll also be doing a couple of other patterns to basically teach you how to solve these kind of problems. And the technique that I'll be teaching you, you should be carrying it throughout, because this technique is going to be used in dynamic programming a lot. Okay, so printing subsequences whose sum is k. Let's take an array as an example. If I take the array as 1 comma 2 comma 1, and I give you the sum as 2, so I can say the subsequences that have sum equal to 2 are nothing like, it can be 1 comma 1, and then there can be 2. So there are a couple of subsequences whose sum is 2. Like whenever I sum up all the elements, I get the sum as 2. So how can you print down all these subsequences? That's the specific question. Now, in the previous question, we were carrying a data structure, if you remember well enough. Over here, can I say that whenever I'm picking an element, I don't need to carry a data structure, or I do need to carry a data structure because I have to print the subsequence. Can I say that whenever I'm carrying a data structure, I can carry a variable sum, and whenever I'm picking an element, I can definitely add it to that variable. And at the end of the day, if that variable summation is equivalent to the summation that's given, I can print it. Well, like, yeah, makes pretty much sense. So if I try to draw the recursive tree, because I'm sure that you're pretty much comfortable with recursion tree as of now. You know that you start with the zeroth index, with an empty data structure, and definitely with a variable sum as 0. Now you know the array is 1 comma 2 comma 1, with this being indexed 0 1 2. So can I say at the zeroth index, I definitely have a couple of options. One is the pick or take, one is the not pick or not take. So if I decide to pick up, I'll be like, okay, I have picked up the zeroth index. Thereby the data structure will be having this value 1, which is at the zeroth index, and the summation is going to increase. That's definite, because the sum has to increase. Thereby the summation becomes 1. And if you have done for the zeroth index, you move to the first index. Simple as that. So you'll definitely have a couple of recursion calls. The first recursion call will be this, and when this completes, then the other one will be done. So the other one that will be done will be one empty data structure, and the sum still stays as 0. So whenever you have the first index, again you have an option. Yes, again you have an option of saying, I can decide that I'm going to take up this element, or I will decide that I'm not going to take up this element. Correct? So if I decide I'm going to take up this element, my data structure will definitely be having 1 2, and the summation will increase. Yes, the summation will increase by 2 and become 3, and it'll definitely move to the next index, which is 2. And the next one, which is not pick, is definitely going to be 2, and it'll just be having 1 and comma 1. Now if you're deciding that you're going at the second index, again you'll have a couple of options of pick and of not pick. So if you're deciding to pick it up, you'll go to the next one, and you'll have like 1 2 1, and the summation will be 4. Over here, not pick, and it'll be like 1 2, and the summation still stays as 3. So whenever you reach this, and you know that you have reached the third index, so you can say that the summation that you got is not equivalent to the sum 2 that you're looking for. So no need to print it. Yes, no need to print it, and you can go back. Now when you go back, now you'll come across to the next recursion, because if you remember well enough, you'll always have this one done, and then you will be doing this. So this one was done, now you will be doing this. Correct? Again, this will not be printed, and it'll go back. So over here, again for this recursion, this was one recursion which was done, and now you go back. So again this recursion will be done. So you're at f of 2. Correct? So if I decide that this will again have couple of guys, which will be, you say pick, thereby this will become 1 1, and the summation will be 2, and it'll move to the third index, and I'll say I'll not pick, thereby stays as 1. So over here you see the summation that you get is equivalent. Thereby, you can print this particular data structure and you'll get your first data structure as your answer. And again, this recursion call will be over, and now this will go, and this will not be printed, and this will be over. So in this way, by picking up the first element, you just got one subsequence. Let's do it for the other one. So I can say you are over here, and again you can decide to pick or to not pick. So if you decide to pick, you'll move to the next, and you'll be like having 2 with a summation of 2. And if you decide to not pick, you'll move to the next with empty and 0. At the second index, again you decide to pick and not pick. So you'll move to 3 and with 2 comma 1 and the summation as 3. Not to be done. Go back. Come over here. F of 3 2 comma 2. Print the data structure 2. Done. Come back. Come back. Go over here. Again at the second index you have a couple of options, pick and not pick. So if you pick, you will get something as f of 3 comma 1 as the summation. Not pick, you'll get something as 3 comma 1 comma not pick, sorry, 0 comma not 0, nothing in the data structure, comma 0. So none of them will be done. So you can just go back. So ultimately, if I put down the recursion tree, you're able to get a couple of guys. One was from here, or I can say if I just do it a highlighter, one is from here and the other one was from here. So if you carefully observe, this guy was pick, not pick, and not pick. Yes, sorry, pick. This was pick. So pick, not pick, and pick, which means pick, not pick, and pick means 1 and 1. And if you carefully observe over here, not pick, pick, and not pick. So not pick, pick, and not pick, which means only 2. So this is how the recursion easily works. I hope it makes sense. So coming across from the previous code, if I'm writing the pseudo code, it's very simple. You carry on the index. Yes, you carry on the index. You have the data structure and you will have a summation variable. So you can be like, if the moment index reaches equal to n, and if the summation is equal to the sum that you're looking for, you can print the data structure. As simple as that. And you can return. And this time, in case of your pick, I'll be like, okay, I'll add into the data structure, add array of index, and sum also I'll add array of index. I can like f of I plus 1 data structure. I can pass on the sum. But this time when I come back, I'll have to remove from the array. I'll have to remove the array index which I've added. And at the same time, I have to remove the array I as well from the sum. And then I can try the other one, which is not pick, which is f of I plus 1, ds and s. So in this way, you can just easily write the code. If you look at the code, this is as simple as it can get. This is the case for pick case. This is the case for not pick case. And there are a couple of things, remove and then remove. Simple as that. So what did I do different? I just added a parameter s. Yes, that's what I've done. And I have added a s over here and I've removed s from the previous problem. But apart from that, if you carefully observe, the pattern remove stays the same of pick, of not pick. The pattern still stays the same. So if I try to code this, let's quickly code this up. If I'm giving you an array like 1, 2, 1, and I give you the n as 3, and I give you the sum that you require as 2, and I say print all these subsequences, which is print s with index 0, and initially you can probably keep a data structure vector of int ds. So just pass on the data structure, and right after that you can just pass on the sum that is like the initial sum is 0, and this is the sum that you require, the array and the n. Okay, so if I'm writing the void function, it's like print s. Okay, and you're taking the index, you're taking the data structure, which is like this. You're taking the sum, and you're taking the sum that you are given. You're taking the array that you're given, and you're also taking the n that's given to you. So the first parameters, the first set of parameters, remember this, are given, are basically your recursion parameters, and these are given to you. Yeah, these guys are given to you. So I can say if I reach the index equal to n, I can be right. Okay, if the sum is equal to sum, why don't you print the data structure? I'll be like, okay, cool, I'll print the data structure. So I'll be like, let's print the data structure with something like this. And I can be like, okay, once you've printed it, you can definitely do an endl. And over here, you can just do a return. Simple. And you can say pick. So you'll be like ds dot push back of array of index, and you can be like summation or s plus equal to array of index because you're picking it up. And when you come back, just make sure you remove it from the summation, and you can say ds dot pop back. Correct. And at the same time, you can call the function which is print s with index plus 1 and the data structure and the new sum and the existing sum and the array and the n. Okay, and over here the not pick condition will be there, which is very simple. You say print s index plus 1 ds s sum array and n. Okay, so if I try to do run, I think this will run definitely. You see, I'm writing codes without compilation errors, isn't it interesting? Okay, so this is how the code will look like. In Java, you can definitely can add a list and you can do the problem. Simple enough. But the concept is important. The concept is very straightforward. You have to use a functional call, and if you're using a functional call, then the concept becomes easier. Okay, cool. So so if you've understood this, let me just modify this problem. As of now, what are you doing? You're printing all the subsequences, yes. But I now modify the question and I say, just print any subsequence, any one subsequence whose sum is sum given to you. Like, I don't want you to, if you carefully observe over here, it's printing two subsequences, but I don't want you to print two. I just want you to print one. So how do you do this? That's a very critical case. Now, you can be smart enough. You'll be like, okay, I'll keep a boolean flag equal to false, and I'll be like, okay, flag is true. I'll just print for the first time. You can be like this. Yes, you can be like this. And over here, you can say if and flag is false, this will definitely print it. Okay, if you see carefully, this is definitely going to print it. Right, it just printed one because you just kept a parameter. But again, this is something which is not preferred, and I'll not recommend you to do use global variables. But instead of that, I'll be teaching you functional methods. Again, a pattern that you have to kind of always keep it in your brain. So remember the pattern. The pattern is very simple. What are you doing? You are having a function which basically calls one function, which is pick, then it comes back, and then again you're calling a function which is not pick, and then it comes back. Now, if in certain way, because this is definitely a function call, which generates a subsequence. Now, if this guy can tell you if by using this pick, by picking up this element and going forward, by again picking and not picking whatever you wish to do, if you are able to generate a subsequence with the sum required, if someone can say you that, hey, you got a subsequence using this particular recursion call, can I say there is no need of doing this recursion call any further because I am only being asked to print any one subsequence. I'm trying different methods of recursion because I'm trying to print all the subsequences. But over here, if someone can say me, hey, I got, yes, I got, there's no need to do any further. I think that will make sense. So this is the technique. The technique to always print one answer. Remember, the technique to print only one answer. This is something which I'm going to teach you now. How do you print only one answer? It's very simple. You will write the function, and in the base case, yes, in the base case, if your condition is satisfied, if the condition satisfied, you will return a true. You will return a true. If the condition not satisfied, if not satisfied, then you will return a false. This is the base case trick. Remember this. This is the base case trick. Okay. And whenever you're doing a function call, you will put that into an if, and you will say if this is true, then return There is no need to go beyond. There is no need to go beyond. Okay, and do this function call, because if this gives you saying key you got some subsequence, then you will return a true, and thereby this will not be further executed. So I want you to keep this technique in your head, because I'm going to show you. But as of now, I want you to keep this technique in your right into your head, straight away into your head. Okay, base condition satisfied, return a true. If the function call is true, return a true, just return a true and go off, or else at the end, return a false. This is the technique that you will be following, and the function will be boolean. You have to remember this technique. So I will show you by changing the code, and then I'll be showing you the entire pattern. So what did I say? The function has to be boolean. Okay, you got, this is the condition satisfied. Okay, if you see this is the condition satisfied, I can say if the condition is satisfied, you always return true at the end. And I can say if this if is not executed, then we will come here and we'll be returning false. Because of the return true, it will never come after line 11. It will not go after line 11 if this if is executed. Okay, so, or I can write an else of condition not satisfied, but yeah, doesn't matter. Condition not satisfied. Perfect. Over here, this is a function call. What did I say? Put this into a if equal to true, which means you got an answer. Return true. No need to erase some ds. They don't matter anymore. Return true. So if this function call or if this recursion gave you an answer, there is no need to do this recursion call. Do you need to do any further recursion calls? No. But if this and this, like just in case this also returns a true, just in case if this also returns a true, you don't need to do any further cases. So you can also return a true. If none of them returns a true, then you have to return a false. A very straightforward one. Now, if I try to run this off, you'll again see that I'm actually printing one answer. Yeah, I'm printing one answer only. Right? Again, you can't be specific that you want to print two. It can be any subsequence, any one subsequence. You can't be specific that this is the subsequence that I want. That cannot be done. But you need to just avoid the future recursion calls if you are getting an answer. Okay, and the technique is very simple. In condition satisfied, return a true. Condition not satisfied, return a false. In all recursion calls, if it's true, return a true. You just have to return a true, so that if someone has called him, you will know, okay, I got the answer over there. So in order to understand this, I will try to write this across by taking this particular example. Let's take the example. So we have a 1, we have a 2, we have a 1, and I'm giving you the sum as 2. What did we have? We have a function. I'm not writing the exact code because I'm assuming the code is in your brain now. So this was the base case, right? Initially, you started off with index 0, data structure empty, and a sum 0. So the base case is definitely initially not satisfied. So what you do is you basically add into the data structure and you go to the next index, add it into the data structure, summation increased with 1, and you call this, correct? Now there is another line, like there will be a line like data structure add, and there will be a line like summation plus equal to, data structure remove, and then summation minus equal to, and then there will be a function call of again 1 empty data structure and a 0. This function call will also be there. But before this executes, I have to definitely complete this. So let's see. F of 1, data structure with 1 and 1, correct? If, again, base case not satisfied. So again, you call this particular stuff with data structure add and summation plus equal to. So it becomes 2, 1, 2, 3. So this, now realize, this call will go. So let's see this call. F of 2, 1, 2, 3. Again, the base condition is not satisfied. Again, if of f of again data structure dot add, again s plus equal to f of 3. This will become 1, 2, 1. Summation will become 4, and this will go. At the moment this goes with f of 3, data structure of 1, 2, 1, 4. The base case says, okay, base case will work, but the summation 4 is equal to 2 will be false. Thereby, you will return a false. So this guy returns a false. Remember this. The base case has been satisfied, and in the condition satisfied, you return a false. Yes, you return a false. Now, the moment you return a false, I was writing the code something like if equal to true, but it did give me a false. And if did give me a false, then I'll be like, okay, now let's remove s minus equal to, and then again call the function for f of 3 without adding that, and let's call this function. So this time this function call will go with f of 3 with 1 2 with 3, and again the base condition will be satisfied because the index is equal to 3, and I can be like, okay, but 3 is equal to 2 is false, thereby I will be returning a false. So this guy returns a false. So none of the recursion calls give you a true. Thereby you come across and say, can I return a false? And thereby this function says false. Perfect, I got a false. So now again I'll be like, fine, let's remove, and then again we will call for f of second index with only 1 and the summation of 1. Let's now call this. Now this function is called. When this function is called, it's like f of 2 with 1 comma 1, and thereby the if is not executed, and it goes to f of 3, and I add the last one, and it becomes as 2 because I'm adding the second index guy, which is 1, if you remember the array. And this case, like you would have added data structure add summation plus, and now this function call goes with f of 3 and the data structure has 1 1 and 2. This is the moment index is equal to 3, true, 2 is equal to 2, true. So you print it, and then you return condition satisfied, return true. So this guy will return you a true. The moment this guy returns you a true, this says if equal to true, because this guy returned you a true, you will return a true. No further recursion calls will be done. Thereby returns a true. Let's return a true now. So this guy will return a true. Thereby this will return a true, and you got a true. So this guy got a true. Remember this. This guy got a true. And if this guy got a true, will you execute this? No, because the moment you are saying if equal to true, you are also returning a true. So return a true. So only the first kind of recursion happened. That's why the technique is very simple. Condition satisfied, return a true. Condition not satisfied, return a false. First recursion call, if it's a true, no need to do a further recursion calls. As simple as that. And if both of the recursion did not yield you an answer, return a false. Very, very common technique that you have to keep in your head forever. I hope that makes sense. Okay, so till now what have we learned? We have learned how to print all the subsequences using parameters. We have learned how to print only one answer, because there will be cases where you will be asked to print only one answer. So it is like whenever there is a recursion call, you don't do other recursion calls. Now, what if I say, I don't want you to print, I want you to give me the count. I want you to write a function which tells me, like for the example 1 to 1 and k as 2, I want you to write a function which tells me that there are two subsequences. I'm not concerned about what are the subsequences. I'm more concerned about you give me the count. If you give me the count, I'm super happy. I don't care. You just give me the count. So again, there's a very simple trick for this. The trick is, if there's a function, on the base case, return 1 if condition satisfies. Okay. Return 0 if condition not satisfies. Call the left function, and remember this will be an integer. Call the left function, whatever you have. Call the right function, whatever you have, and return left plus right. This is the simple structure. If you are being asked to count, there will be questions where you will be counting. In entire dynamic programming, you will be facing this. So this is the very straightforward structure that you have to maintain. If there are multiple recursion calls, you can go on like LR, YZ, XYZ if there are multiple recursion calls, right? And if there are multiple recursion calls, you can also keep it something like this: S equal to 0, and then you can write like if there are multiple recursion calls from 1 to n, then for every recursion call, you can just add it up and then you can return S. So this is basically saying there are n recursion calls. Over here there are only 2 recursion calls. Over here there are n recursion calls. So you add up all the recursion calls and then you return. Over here there were 2, so you can write like L plus R. So you will see this pattern in N Queen, which is the upcoming problems in the playlist. You will see for loop being run and being counted. But over here, we are dealing with count the subsequences of sum is k. So if I go to the code and I try to change, I can be like, okay, it's an integer. What did I say? In the base case, if the condition satisfies, it's a 1. And if the condition does not satisfy, it's a 0. And what I'll do is, I will be like, okay, I'll keep the left, like over here, everything will change now. I'll be like int L equal to this. You just see the pattern. It's very simple. Same code, same everything. I'm just changing it so swiftly. Int R equal to this. Changed. And this is L plus R. Okay. So again, there's no need to print it. So no need to print it. Condition satisfied. Simple as that. If condition is satisfied, you return 1 or else you return 0. Okay. And add up all the possible methods that you're trying. And over here, you can just give a cout. And now there's no need to carry the data structure. So I can just remove the data structure. Because we don't need to take the element. Do we need to take the element this time? No. So we can just simply remove the data structure. And from here also we can remove this. We can also remove this from here. So I've removed the data structure from, I think, almost everything apart from here. Let's remove it from here as well. So remove the data structure, and now let's try to run it. So if we try to run it, you will see the number of subsequences do come out to be 2. Do you see over here? It's being 2. So very simple pattern. Condition satisfied 1, condition does not satisfy 0. And similarly over here. Just take the left recursion call, right recursion call, and add it. This pattern, you have to keep it in your brain forever. I repeat, forever. So if I show you the dry run again, I'll show you the dry run. If I'm writing f of 0 and the sum as 0, and the base case is definitely not satisfied for the first case, and I'm saying L equal to f of 1 and the summation will be 1 because for the first time I'll be picking up, and R will be f of 1 and for the first time I'm not picking up. Let's return L plus R, whatever it comes up. So let's go to this case. So if I'm going to this case, which is f of 1 and the sum is 1, again the base case will not be satisfied. L will be f of, you go to the next and you add up the next element, which is, if you remember the array looked like something like this, 1 to 1. So the next element added will be 2. So summation will become 3. And R will be no need to add. So it will be something like this. Thereby this function call will now go. And over here, remember, return L plus R. F of 2 comma 3. So f of 2 comma 3. Again, the if condition will not be satisfied. So you'll be like, okay, left will be f of what? F of 3 comma, the last element will be picked, 3 comma 4. And the right will be f of 3 comma 3 as it stays. So this can be picked, this can be not picked. So if it is picked, it's like f of 3 comma 4. So if you carefully observe, the base case is satisfied because index is equal to 3. So thereby, if 4 is equal to 2, is that? No. So else will go and you will return a 0, stating that this subsequence cannot be the part of your answer. Got it? So I return 0. So what I am saying is, by trying this method, I did not get any subsequence. 0. Okay. By trying this method, again, now this will go f of 3 and 3. Again, the if will work and this will also return a 0. So basically, by trying both of the methods, I did not get any subsequence. So I will say return L plus R, which is 0 plus 0, which is 0. So I'll return a 0. Thereby, by trying this method, I did not get any subsequence. Now this one, 2 comma 1. F of 2 comma 1. If I try this, if will not be executed. Now L will be f of the next index and 1, the second index will be picked. So if you remember the array, it was 1 over here. So 1 plus 1 will be 2, and this now goes. And there will also be an R where you say you will not pick anything, pick and not pick. So when this goes, it's like f of 3 comma 2, which is 3 equal to 3, and you say if summation is equal to 2, which is the case, you return a 1. So you are saying by following this case, I got 1 subsequence, and by following this case, you will go and this will return a 0. You got 0 subsequence. So you will say return 1 plus 0, which is 1 subsequence. Thereby, I got 1 subsequence. So again, 0 plus 1. So you got 1 subsequence if you picked up the 0th index. Again, makes sense, because if you pick up the 0th index, you're bound to get 1 subsequence, which is this 1 and 1. So you got 1. If you try again not picking, you can again go on, and this will return 0. So this will also return 1. So 1 plus 1, you will easily get as the total number of subsequence as 2. Why did this work? Because you went on till the end, and at the end someone said you, is this a valid one or not? And they returned a 1, and you just kept on counting. That's why this technique works. Remember, very straightforward, no need to complicate. Base case is where you have to return 1 or 0, and all the recursion calls that you make, summarize, because every recursion call will go and end up at the base case, and the base case will tell you, does this recursion call give you an answer or not, and you have to just sum it up. As simple as that. So coming across, what is the time complexity? Again, there are n indexes, and for every index you're saying I'm gonna pick it up or not pick it up. So there are 2 options for every index. So if there are 2 options for every index, it is 2 to the power n. We can optimize the time complexity a slight. How? We can probably write one more base case, again multiple base cases. I can write one more base case where I say if s by chance goes over sum, you can return a 0, because this can never satisfy the condition. Going forward, condition not satisfied. Again, this can only be strictly done if array contains positives. If array contains positives only, then I know by picking, not picking, I cannot again come back to sum. So this can be additional you can do, but on the worst case, you have to travel all the subsequences. This is how this can be done. So I hope guys you have understood all the patterns, how to print. Again, to a quick recap, print is parameter wise, how to print one answer, return true or false, and avoid further recursion calls. If you get true, how to count any problem. You will get in the future, you'll get a lot of problems where they'll say count. So whenever there is something like count, return 1, return 0. This is the funda. And add all f and return. Simple as that. So I hope guys I was able to make you understand all the varieties that can come up. Okay, so just in case I did, please make sure you like this video, and if you're new to this channel, please do consider subscribing. Please do consider subscribing. And yeah, with this I'll be wrapping up this video. Let's meet in the next one where we will be solving something else in the recursion failures. Bye bye, take care. Whenever your heart is broken,